My name's Andrew Hartnett. I'm a VP of Engineering at New Relic, and I run our core data platform. This is the platform by which we ingest all of the data from the millions of different points and customers from around the world. We translate it, mutate it, do all the things, and get it to rest and make it queryable, both directly to customers and for other products that sit on top of our platform. Normally, when I'm in a speaking engagement, years ago, somebody told me always tell a little joke. And 4 weeks ago, I was at the Kafka Summit in Austin, and I told a joke in front of 2,000 people, and it completely bombed. So I'm not doing jokes anymore, at least for a while. My presentation today is entitled "Writing the Request Tsunami." I thought that was a fun title to sort of describe what we've been dealing with over the last several years with our growth. Let me move on. Real quick agenda. Basically what I'm here to talk about is the lessons learned and what we've done, but I'm going to set it up by talking about our migration from our existing data center into the cloud. And this is when CDN and using the tool like Compute@Edge became important for us. So I thought I'd start off by laying that sort of groundwork. And then, at the end, like, where are we going next? And a couple key takeaways. So New Relic, for those of you that are not familiar, we're an observability platform that helps you build better software. It gives you access to the data that you need so that you can make decisions based off of data, not opinion. Years ago, New Relic started in the APM space. That's where they sort of started their growth. And now we're ingesting logs, network data, security, infrastructure, you name it. Our all-in-one platform handles all of that. And then I love this mission statement: help every engineer do their best work every day using data, not opinions, at every stage of the software lifecycle. And the only part of that I would change is every engineer, because these days we're seeing a lot sort of shifting to the left. Product owners and product managers are starting to use and determine what's next for them. What are opportunities that they should be going after by looking at the data? And even into leaders who need snapshots before they get on a stage and talk to somebody. So we're seeing this sort of pattern of it's not just the ops, it's not just the engineers, but others as we shift into new data types and new ways of serving that data. So here's some of the problems that we're dealing with. Our current ingestion right now, up to 7 billion points of data that we're ingesting per minute from around the world. I think we're now at about, this slide is about a month old, but we're about 240 or 250 petabyte that we're ingesting per month. And then, on some of our more busy days, around 300 billion HTTP requests. And added to other scalability issues, I think we're at 117 different engineering teams, over 800 services in just sort of our query. We have, had over 14,000 JVMs running. The way that our architecture was set up, an issue in any one of our major systems was a bottleneck and created problems down the whole pipe. And it did. Back when I was a customer of New Relic, I remember in 2019 experiencing some issues and sending a few emails saying like what's going on. And some of this was because we had hit the physical limit of the data center we were in. We had to move, and we needed to move to the cloud. So I love this slide, a little animation. It was time for us to modernize. And everybody knows the reasons for choosing a hyperscale cloud, being able to stand things up quickly. And then for me as a pattern, and I'll be talking about this a little bit during the rest of the conversation, is I didn't want infrastructure to be a core competency that we had to have. I want my teams, I want my organization to be able to focus on our customers. What value can we provide to our customers? I think being an infrastructure engineer is not something that provides the value that I think we should be delivering. So real quick, we'll just sort of walk through the migration to set this up again. So on the right, as you're looking at it, you see sort of what I call a snapshot of our data center. And it represents a core set of services that we call our data plane or our data zone. And what we've done is we basically took a snapshot of that and we started imprinting that all over, starting off in AWS and then to Azure, multi-regions. And what we want to do is we want to get closer to our customers. But as we were doing that and we were migrating, we needed to deal with something new that we didn't have to deal with before necessarily, and that is CDN and smart routing, because during our migration, data could be in multiple locations at once. And actually, with our cellular architecture, by design, our customers' data is spread out all over. So we needed to know where that was, and we needed to know that when requests were coming in for that data, and when requests were coming in to actually place that data. So we created this routing layer. Now, I'll talk about this in a little bit, but from this slide, just have an understanding that what we call cells, if I say cells again, it's our data zone, and it's a snapshot of our infrastructure that can store and then surface data back to our customers. So again, we had to solve this problem, but the two big questions is which shell should the data go to, and then how does it actually get there? So initially, our architecture looked like this, right? We had a partnership with another CDN provider. We had a routing system which helped us determine where everything is, that sort of quick communication, and then we routed to the different cells or back to our legacy data center while we were still going through the migration. Because it took us about 10 months to fully migrate all of the data and all of our customers' accounts out of the data center into the cloud. And we called this account-based routing, and it was a simple version of routing. We just looked at the account and we said, okay, spread it around, and then this cell has this account in it and this amount of data, and so we just knew where it was, and we could pull it back out. And we implemented using the edge provider that we selected at the time with the routing tool that we called Wayfinder, and things were okay. Some of the other things we wanted to do with our edge routing solution was we needed to reject traffic from certain locations, certain countries, right? For various reasons, we can't accept data from places. The other is that, again, I want to manage service. I don't want to have to maintain POPs. There are companies like Fastly that do that well, and so didn't want to have to spin up whole new teams in order to go do these things. And yes, the fact that someone else is on the hook for it makes me feel better. They have their own SLAs. We make sure that they're sticking to them. And so just real quickly, how our migration went. We added that smart routing layer first. It had to be there. But we did learn some important lessons. Not solving this first would have really sort of hampered our migration. But we moved all of our data in 10 months. So our whole data plane, the massive amount of data, all of our customers, we moved to cells. And I love this. This is called I affectionately call this the Sherbert chart. And what it shows is, we're moving out of the data center on the left, and each one of these sort of rainbow colors represents a different cell that we've spun up here or here or here. And this represents, as of a year ago. And so if I were to pull this slide up again today, there would be, triple the number of separate sort of cells that we have. So I think we did it in 10.5 months. I say 10, but I think technically it was 10.5 months. 100% of our data ingestion is now handled in the cloud and not in the data center. So, lessons learned. So for us, we're an observability company. So just very quickly, when you're doing something like this, observability is key, right? Having an understanding and have everything instrumented so you do have that understanding of where everything is at all times is very, very important, especially when you're dealing with customers' data. They don't like it when you have misplaced it or can't find it. But for us, it was easy. Everything we do is fully instrumented, but I just wanted to point out that it is key. And I know I said, just another slide, but I know I said that observability is key, but redundancy is actually key. And so for us, we started having some pretty major problems with our CDN provider. And this caused downtime. This has caused issues with customers. And then doubly, I think I was talking with Larry or Sean last night, Larry from CNN and Sean from Paramount. What also was interesting about when we don't receive data, not only do I get a call from a customer saying, hey, where's my data? Because of the business model we're in, I don't actually get to charge for that data. So I'm getting yelled at by a customer that I didn't even get paid for, right? So we needed to solve this. We needed to have a redundant CDN partner, and we reached out. We had Fastly already in-house working on some things for us, and we moved to looking at their compute at edge. Fastly has the ability to handle our scale, which was one of the top concerns. Reliability is a second concern. Their underlying core network is just solid, it's dependable, it's fast. And then, we've worked on additional features that we needed to be in place. It turns out I actually, in a previous life, a couple companies ago, worked with the product manager for Compute at Edge, and so I'm feeling like even more sort of synergy now, which is awesome. But what we have now is the ability for us to split traffic and to be able to route around specific vendor issues. Part of what we also enjoy about this is the relationship, the partnership, and I'll talk about that in a minute, but it's key. The fact that we both consume from each other feels really good. Fastly is uniquely built to offer this sort of greater control and reliability, which is evident in their UIs, in their APIs, in their CLIs, and specifically with Compute at Edge and our platform combined, businesses can use us together in order to really have a holistic real-time view of their network stack, and developers have the tools to get the information that they need. Last one, this is just in general, don't ever plan totally for the happy path, because I'm an eternal optimist, and I always see the good, and I always feel like things will just work out, but sometimes they don't. And so make sure that you have a plan. I go back to Agile 101 all the time. Iterate, take small steps, figure out which direction you need to move after you complete that small step. We've had things bite us, and we've had to get creative in order to sort of work around them. And this was one of our examples, relying on a single vendor in order to handle all of our CDN. So what's next? I mentioned that our data zones are all over. We want to get them even further all over. Part of what we do is we've kind of defined that snapshot, and I call them cells. How can we actually get those to the smallest possible set of services and infrastructure so that we can get into even more places? And probably more importantly, how can we not spend a ton of money in going into those locations? So, for example, if I want to go into GCP in their Singapore location, it shouldn't cost me $500,000 a month to spin up a massive set of infrastructure to go after customers there. I should be able to have a small, lean set of infrastructure that I can deploy. So that's next up for us. Some of the things we have also learned is the initial sort of lift and shift that we did into the cloud. That's a pattern. but that pattern always needs to be followed up with optimizations. And so over the last 6 to 9 months, we've been doing a massive set of re-architecting of our services to become cloud native, to really be able to have that sort of minimum level of infrastructure that can then auto scale. We are going to continue working on that. And lastly is shuffle sharding. I mentioned account-based routing, right? So when these requests come into Fastly and we're looking at them right now, everything is keyed off of the account. What we want to get to is to be even smarter. We want to be able to maybe not spread it everywhere, but spread that account amongst a cluster, a virtual cluster, if you will. But then use things like, what is the state of that cell? Does that cell have a lot of I/O capacity? Does it have CPU capacity? Because all data is not the same. And when we ingest it and we make it available, it has different sort of patterns across our infrastructure use. And so being able to look at the health and network issues here and there and know you should probably route over here based off of more than just the account. So that's one of the things we've got coming up next. And then for takeaways, really simple. When you're dealing with massive scale, things can get complicated. We discovered that we needed the second point, which is redundancy, more than we had initially designed. Redundancy across your critical systems is very, very important. And then I'll add 2 notes. Finding a vendor that can scale with you is very, very important. And then lastly, that vendor should be a partner. And I'll say, having dealt with hundreds of vendors over my career, that the relationship with Fastly started off great, and we push each other, but it's been a great partnership, and I look forward to more as we define what else are we going to move to the edge. Thank you very much.